Okay, hello there. We're doing that last 1D dynamic programming problem, partial equal subset sums. As you can see, this is our 103rd problem. We've finished all our 1D dynamic programming problems. This is great, but we're not finished yet because we haven't done it. So in this problem, we are looking at an array and seeing if we can create a subset that would guarantee us two equal subsets. So one thing that means is that the total items, the total sum of all these numbers, like sum of nums, these numbers must be an even number. If it's not an odd number, we can't partition the array in a way that would give us two equal items, because one will always be less than the other, or one will be more than the other. Anyways, so if total sum modulus 2 is equal to 1, return false. Okay, next thing to note, if we're going to, if they are even, then we can continue and look at the items. So suppose we're doing a subset. This is the most brute force way to think about it. 1, 5, 11, 5. So we can select a 1 or 0, and then we can select a 6 or a 5, or a 1. And from 0, we can select a 5 or nothing again. So this is, you can really see this is 2 to the n power. As with every decision that we make, we are creating a new branch in the tree. So this is 17 for 11, or just skip this 11. Take the 11, skip the 11, take the 11, skip the 11, take the 11, and skip the 11. But once we've found, see, this is 8 items here. So once we've found 11, and 0 in our possible sums, then we can submit our answer saying true. But so given this problem, what we're trying to do is to find out if we can find if there's a sum of numbers in this particular array that would give us 11. And one way to do that is to create let's say a set of numbers and generating them into a way of, let's say we generate a set of, we have 1, we have a 0, and that's our base case, and then we can add a 1 to it, and that would be a new number. And we keep these numbers going, and we add another number, let's say 5. 5 plus 0, 5. 5 plus 1, 6. Okay, great. And we can continue going. 11 plus 0, 11, then we're done. But let's keep going. Let's see how many results that we can have. 12, and 11 is 16. 11 plus 6 is 17. Then we have a 5. We add all these numbers to it. So it looks like this is going to be 5. Oh, 5's in there already. Add 5 to 1. 6 is in there. 5 to 5. 10. 5 to 6, 11. 5 to 11, 16. We have that. 5 to 12, 17. We have that. 5 to 16, 21, and 5 to 17 would be 22. And those are all our possible numbers. So each time, the runtime is going to be the total number of sums possible with the items given. So this would shrink we go from 2 to the n power to the number of sums possible but in the array. So with that, I think we can get to coding this particular solution. And so what happens is, for n in nums, we need to create let's say a DP of set and add a 0 to it. So to start us off, and for each number, what we're going to do, as we have just said, is create a next DP, and that's going to be equal to an empty set, and we're going to add all these numbers in for because we don't want to compound our numbers. So for n, let's say not n, let's say m, or let's say sums in DP. Let's do next DP dot add. Let's get the total is equal to sums plus the new number. Let's add the total, and let's add the previous sum. And if the total is equal to our target, then we can also return true here. That's what our ideal, right? And with that, we can return false if the answer is not found. And that's all. So, run the code. Oh, if total equals, oh, we don't have a target. Right, the target is equal to the total sum divided by 2. And that's true. Let's return it one more time. And, oh, we are false. Why is that? Let's see. Oh, right, my bad. I forgot to say next dp equals next dp because we need to reset the dp. I don't know, like the last one passed because it did not need to reset. But with the reset, we are getting a pretty fast time here, and we have solved this dp problem. The question is maybe how did you come up with this particular solution? It's about asking questions. I didn't come up with this myself. I looked towards others like Neetcode for the solution, and hopefully by implementing the solution multiple times, it would be ingrained into my brain that this is the path of dot, and the path of dot is to go do the brute force, take a look at what you're trying to do, ask the question, oh, what am I actually looking for here? I'm actually looking for to add the items to our total and figure out what type of sums that we can get, and if we can get to the total sums divided by 2, our target. And that simplifies our problem so that we can write an algorithm that would make that possible. So it's about asking the correct questions by getting observations, and to get these observations, we went through a brute force method. And if we want to, do this at an interview, that's how we would do it. Something else is that we just need to work on more problems. Just see more ways of doing the brute force and see if we can make those observations, make that jump, and observe those things. And if we observe those things enough times, it will build up a pattern recognition for ourselves, and we would be able to see it during an interview. And that's all. So keep coding, and I hope you learned something today. If you want more videos, check the link in the description below, and thank you very much for watching. I'll see you in the next one.